Hello everyone, so in this video, let's talk about the problem C of the Codeforces round 529, division 3, problem name power of 2. So as you can see, a positive integer x is called power of 2 if it can be represented as x can be represented as 2 to the power of y is a negative integer. So the power of 2 are this number. So any number that is like represented as a 2 to the power of y is a power of 2. Pretty much simple enough. You are given two positive integers n and k. Your task is to represent n as a sum of exactly k power of 2. Okay. As you can see, you had given n and k, and you have to represent, let's assume n, that is 9, as the summation of k, like this is 4, power of 2. So you have to just represent this as k power of 2s, and if it is possible, represent yes and the numbers, else represent no. So whenever I think this exactly power of 2, let's keep that aside. You have to first represent n as a sum of power of 2. Whenever you see that you have to represent something as power of 2s, it's pretty much simple that you have to go in the binary representation of that number, or maybe you can say bit representation, because in bits everything is power of 2. You have to do in bit representation. Now what you can directly do is, let's see that what is the minimum number of sum of power of 2s I have to require to get a sum of n. So what you can directly do is that you can find out the bit representation of n, and whatever bits are set, just take that. Whatever bits are unset, then don't take that, and you will get the sum of the minimum number of elements whose are power of 2s, whose sum is equal to n. So let's assume if you take 9, 9 is, let's assume 1 0 0 1, which is like 8 plus 1. So 2 to the power of 3 plus 2 to the power of 0, which is 1. So this is the minimum representation you can get as a power of 2s to get this sum that is equal to n. Now, the problem is that I want exactly k. And now I have here two elements. You understand what I'm trying to say? Because if I get through this process of finding out the bit representation and taking out all the values which are set and not, in that manner, I will get two elements that are 8 and 1. But I want, let's assume k, exactly k elements, and k is equal to 4. So I want 4 elements. So what you can see is that because I want exactly power of 2's only, I cannot make this power of 2. I can divide this into 2 power of 2's. I can make this 4 and 4. So if I divide this by 2, if I take whatever number I have in this list, whatever are greater than 1 and whichever are power of 2's which are here, I can still divide them into two more numbers, like divided by 2, so that I will get two same numbers which are again power of 2's. If I And by this method, now I have 4 plus 4 plus 1, because 1 was already there, and I've divided 8 into 4 plus 4. So now again the sum is equal to 9, but now I have 3 elements. And similarly, I can do the same thing again and again until I have k elements, that I will again take whatever number I have which is greater than 2 or greater than equal to 2, that is a power of 2, and I will keep on dividing into 2 elements until I will get k elements. So the edge cases are that if I'm not able to get k elements after dividing everything, then the answer is no. Also, as you can see here, that let's assume I got two elements after in the bit representation. I get two elements. The minimum elements I will get after dividing n into its bit representation is two elements. But if in this problem the k is equal to 1, which means I want exactly one element, I cannot get, because the minimum number I need to require to represent this number is 2, 8 plus 1. But if they required, so whatever number I get as the minimum number required to represent this, if k is less than that, in that scenario also there is no answer. Else in all the other scenarios, I will keep on dividing these numbers until I get k elements, and I will just print out. That's the complete logic and the problem for this particular problem. Let's move on to the code part now. So as you can see here that we have n and k. So we have taken a map and a cube. Okay. map is used to represent whatever numbers that we have. So we'll iterate over first all the bits, and whatever bit is set, I will like add that number in the map and also in the queue if that number is greater than 1. So what this means that, see, I have to have the list of numbers I want to print, because whatever numbers I have, so I will keep on appending those numbers in map. But if the numbers, if the k, the number of elements I get are less than k, whatever numbers I will get, let's assume after representing it in the bit representation are less than k, I have to keep on dividing that. So for that I need some sort of data structure in which I get all the numbers what I have and I will keep on dividing. Let's assume I have numbers like this 8. Then I can divide 8 into 2 more elements, that is 4 and 4. So I will pop out this from the queue. I will use the data structure queue and then push 4 and 4. Then 4 is in the start. I will take out 4, push 2 and 2, the back of the queue. Then I'll take out 4, I'll again push 2 and 2. So it's like a queue. So that I will keep on taking out elements from this queue to divide it until the size of it becomes exactly equal to k. So I will insert in the map whatever elements I have and again in the queue, but I will only push in the queue if the elements are greater than 1. Because if it is 1, I cannot divide it any further in the queue, so that's fine. Then if the count is greater than k, which means that if I have represented in the minimum form and if the size is already greater than equal to k, I cannot make it equal to k, so answer is already no. Until then what I will do is I will keep on doing a while loop. In the while loop, if the count that we have, whatever count, let's assume the count I get with the minimum representation of this number in the bit form is count. If it is less than k and the queue is not empty, I will take out the first element from the queue, subtract its frequency from the map, because map stores whatever element is there. Okay, we'll subtract it from the map, and because I've taken, let's do 4 out of here, I have to divide it into two twos. So I will decrement the count of 4 in the map, but increment its half value, because now we have to divide 4 into 2 and 2. So which means that now we have element 2 and 2. So then 2 and 2, because now we have added, like subtracted 4 from the map, which is like the which is using to store the count of whatever final elements that we have. But we have subtracted that 4, but we have now added 2 times 2, because now 2 times 2 has occurred, because we have subtracted that. And I will now, because this 2 and 2 we have to keep on reinserting inside this queue, so that I can retake it if my k or the count I have is still less than k. So if there is greater than 1, because then only I can keep on dividing, I will push that 2 times, because if I have divided 4, I will push 2 times 2. That in the next iteration, or maybe in the other iteration, I will take out 2 and I will keep on dividing it again. Okay, and because in this whole scenario, initially let's assume I have two elements, 8 plus 1. I divide it into 4 and 4. So now the total elements I have is 3. Because in one division, I have incremented the total number of elements with me by 1. So I will increment the count by 1. And I will keep on doing it until the count is less than k. If it becomes equal to k, then I'll break out. When I'll break out, or the queue becomes empty. The queue becomes empty, or I have reached the k. If I have broken out and the queue becomes empty, which means that the count is still less than k after making everything equal to 1, the answer is no. Else, I will print out yes, that yes, we have the answer. And in that answer, what I'll do is that we have to print out in the map. The map is storing out the element and its count. Okay, so I will just iterate over the map, simply iterating over the map using this for loop, and whatever the element is in the map, I will print out that frequency, because I'm storing out the frequency and the element itself, that number of times, and I will get the answer. That's a particular logic in the code part for this particular problem. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one. Till coding, and bye.